Good afternoon, everybody. Welcome to this Workplace Health Expert Committee seminar. My name's Andrew Curran. I'm HSE's Director of Science and Chief Scientific Advisor. It's a great pleasure to welcome all of you to this event. We have got a little bit of an issue in that one of our speakers, Professor John Cherry, is based in Edinburgh and unfortunately have a power cut in Edinburgh at the moment. So he's not able to join us quite yet. We're hoping that somebody manages to replace the fuse somewhere in the system before the end of the seminar so that John can make a contribution. But I'm really pleased that Professor Len Levy has agreed to bravely step in and fill John's slot for us. So if I can start with a bit of domestic. Can I remind you that the seminar is going to be recorded, so it can be accessed after the event. Question and answer session will not be, so if you have any questions, they won't be available after the event, and we'll disseminate that afterwards with captions. If you can think about questions as you're going along and submit them into the Q&A button, that would be really helpful. And then my colleague Adam Medder will run a Q&A session for us at the end of the seminar. So thanks to Adam for doing that. If you could also, when you are looking at the questions, use the thumbs up, the like button, then we can ask the questions in the liked order. That will be really helpful. And hopefully it's a way of just making sure that you can capture your thoughts as the speakers are speaking rather than waiting till the very end, which hopefully will give you a bit of time to make sure that the questions you're asking are good questions that keep the panel on their toes. So just by way of introduction to the Workplace Health Expert Committee, this was a committee that was set up a little while ago now, because when in HSE we're developing policy, we need to make sure that we're informed by the best available up-to-date evidence from the scientific literature. And WHEC was formed, therefore, to provide that independent expert advice, particularly around new and emerging workplace health issues. And clearly within our new strategy, protecting people and places, health is a very important theme, particularly in relation to mental ill health, but broader occupational health issues as well. This seminar is talking about some of the work that WHEC did for us, looking at the carcinogenicity of welding fume. And what we did here was, following the International Agency for Research on Cancer review, we asked WHEC what their opinion was regarding the potential for welding fume to be carcinogenic, so that we could provide an appropriate response to that in our own policy activities. So I'm going to hand over to Len. Many of you will know Len. He's extremely well known in the field and is currently Emeritus Professor at Cranfield University, having formerly been the Head of Toxicology and Risk Assessment at the MRC Institute for Environment and Health at the University of Leicester. Len's background is as an occupational toxicologist with a particular interest in occupational cancer. Has been a member of WHEC since it was set up, and has been a member and observer of many IARC monograph meetings, including the meeting on welding fume and cancer. So, Len, with huge thanks for stepping in and covering John's area, it's over to you. Thank you very much indeed.
Yeah. Thank you very much, Andrew, and hello, everyone. Okay, first slide, please. Right, we'll start out with almost the conclusions in a kind of way. I mean, there are two to do with the evidence itself, and essentially two to do with the control of it. Now, this WHEC opinion reviewed, as Andrew said, the latest IARC evaluation on the link between exposure to welding fumes and various forms of cancer, particularly the lung, And essentially, we concluded this IARC evaluation was a thorough exercise and agreed with their conclusions that welding fumes can cause lung cancer, ocular melanoma, and may also cause kidney cancer. I'll mention a little bit more as we go along now. The conclusions on the control side are essentially that effective control of welding fumes can be achieved using good practice for control. That's as said. And UV protection is very high during UV exposure during welding can be very high, and great care has got to be taken to protect the eyes. Next slide, please. Right, well, as you all probably understand, welding fume is an incredibly complex aerosol mixture. It's called fume because it's a mixture of gases and very fine particulates in the respirable and nano range. And the composition is going to be incredibly variable depending on the welding method and the materials used, both what's being welded, the workpiece, the rods, the shielding gases, and so forth. And of course, welding fume is not the only substance that might be carcinogenic to which welders might be exposed. As you understand in the past, and even to some extent now, asbestos for protection purposes is there, and for degreasing trichloroethylene, a carcinogen is also present. And also exposures during welding can cause other diseases and which may affect welders' health. And of course, apart from their exposure to welding fume, there are lifestyle factors which have to be taken into account, such as smokers, when you're looking at cancer output. And that's obviously done in the epidemiology. Next slide, please. For those who aren't familiar, IARC evaluations are still considered to be the kind of gold standards in cancer classification. It was set up in '69 in Lyon at the International Agency for Research on Cancer as part of the monograph program, as part of what they do. And it's evaluation of the carcinogenic risk of chemicals to humans on individual chemicals, but they expanded this away from just chemicals alone to look at complex mixtures such as welding fume, lifestyle factors and biological physical agents, as well as just looking at occupations where the kind of exposures might be incredibly complex. The monographs are based on reviews of all the published data that's available in that area for agents to which humans are exposed, and to evaluate this data in terms of the human risk. They use international working groups of experts. They're ad hoc, but they're not permanent, they're ad hoc, called together just for the purpose of looking at the evidence on carcinogenicity in related fields. And they indicate, obviously, where, if they can, where extra research might be needed. So the evidence is obviously best based on human data. So epidemiologists, if there's human data. If it's animal studies, they use animal toxicologists, they use occupational hygienists and chemical exposure scientists, as well as mechanistic experts. So there's a full range of expertise available to produce the evaluations. Next slide, please. What's developed over the years is that they've evolved in the way they've done it, and they have now classifications. They started out with evaluations in the early days based separately on animal and human, but now there's an overall classification which pulls all the data together. And they use 1 of 5 classifications, and it's really based upon the strength and reliability of the available evidence they've got on human cancer and in animals as well as humans. It's important to recognize that there's no regulatory status of these evaluations or classifications. They're advisory, although some countries and agencies use them as part of their regulatory framework. Now, what they standardize now is Group 1 is carcinogenic humans. 2 is now split into 2A and 2B, based again on the strength of the evidence. 2A is probably carcinogenic to humans. In other words, we think it probably is, but the evidence is not quite complete, so more studies could be done. 2B is the agent is possibly carcinogenic, and the majority of those are based on animal studies where you don't have human data. Group 3 is where they are not classifiable, and that's often confusing because it could either be because the evidence is equivocal. It can be read in either direction, yes or no, or there's simply not enough evidence to make an evaluation. Group 4 is not used these days. It's where you're saying it's not carcinogenic, and that was only used for one material. They don't think they use it anymore, and that was caprolactam, used a long time ago. But essentially, you've got the 4 above. Now, next slide, please. This new evaluation was done in 2017 working group and published in 2018. Included that welding fumes, regardless of their composition, are carcinogenic to humans, i.e. to welders in this case. And their evaluation was there is sufficient evidence. Now, sufficient, if you look at the preamble of IARC, it's got a very definition. It means this, it's as sure as you can be on the data. You don't need to do more research necessarily to prove this. For the cancer of the lung, and limited for the causation of cancer of the kidney, which means limited in this case means, well, it probably is, but it would be nicer to get some further studies. And for the first time, IARC assessed the link between welding and ocular melanoma arising from UV radiation and concluded this is also carcinogenic and put it into group 1. Next slide, please. Now, why is this evidence base better than the previous one? There was done one, in fact, I was at that one in '89. That one simply looked at welders as an occupation. In this one, they've looked at all cancers, other reported, so they've looked at kidney, ocular, and other cancers that have ever been mentioned or looked at, as well as other illnesses such as asthma, bronchitis, cardiovascular disease, lung function changes, neurological orders, and kidney dysfunction, where cadmium, which used to be used much more. And so it's quite useful as a monograph, as a source of general information about welders' health. Previously, they classified IARC, as I said before, in '89 from welding, but this time they've classified welding fumes from gas arc welding rather than as an occupation. So it's gas and arc welding, all forms of gas and arc welding where fumes were involved. And also to select the most relevant informative studies, the IARC working group focused on studies that reported risk estimates associated with workers of welder exposure to welding fumes and left out those studies that were less specific. In other words, there were enough studies to exclude those that were uninformative. The ultimate result was they ended up with over 40 studies, 20 cohort studies, and an equal number probably of case control studies and a handful of other studies. So there was a good solid database of reliable informative studies. Next slide, please. The questions that WHEC were asked by the Health and Safety Executive were 3, essentially. Firstly, does WHEC agree that there's sufficient evidence in humans for all welding fumes causing lung cancer? Now, the emphasis there on the word all, and not distinguishing between different kinds of welding, and also limited evidence of kidney cancer. And secondly, does WHEC agree the evidence of the IARC monograph means a distinction cannot be made between welding fumes of different types, i.e. stainless steel versus mild steel? Now, these two form the bulk of most of the studies on welders, and in fact most welders, or between fumes generated from different welding methods in terms of carcinogenic risk of long term, because over the years people have tried to draw a distinction and intuitively felt that stainless steel welding, and there were some earlier studies that suggested that stainless steel welders might have had a higher risk because they are being exposed stainless steel welders to chromium hexavalent chromium 6, which is a known carcinogen. So kind of intuitively you felt, well, if there was a risk, it might be related to individual components. That wasn't the case now. And thirdly, does WHEC agree there's sufficient evidence that exposure to UV radiation causes ocular melanoma? And again, IARC didn't distinguish between the two. And do we agree with that? Next slide, please. Ocular melanoma, it's fairly straightforward. UV exposure we know is a risk factor anyway for skin cancer and melanoma, and is in this case a risk cancer for ocular melanoma and skin cancer, both for malignant melanoma and non-melanoma skin cancer, things like squamous carcinoma and basal carcinomas. The IARC working group considered evidence for ocular melanoma, and there were 8 quite good case control studies in 2 good cohort studies. Most of the case control studies showed an increase for welders of between 2 and 10 times the risk, and there were positive increase in risk with the length of time working. So you've got some kind of metric of exposure, in this case duration, in 2 of the studies. We always like to see, as well as a positive result in terms of an excess, a dose-response relationship. It gives you more confidence about the reliability of any conclusion. The 2 cohort studies gave equivocal results, although there were only small numbers of melanomas in these studies. And there was no useful data to distinguish between the type of welding and the metals welding. Next slide, please. Now, for lung cancer, most of the 23 case control studies and 28 cohort studies evaluated, quite a large number by the working group, showed a positive association between working as a welder and risk of lung cancer, as a simple fact. And also there was a consistent positive association for both arc and gas welding. Some of the studies tried to look at exposure response. As you know, it's quite difficult for welding, where you have different kinds of protection of control and also personal protection involved to get a good idea of the exposure. And often people simply use yes or no to welding, but in this particular case, duration of welding as a metric. Some case control studies estimated cumulative exposure, trying to spend time doing welding using assessment of intensity, probability, and frequency. So a lot of quite complicated work was carried on there. Next slide, please. Amongst the studies that IARC working group looked at, there were 4 very large, well-conducted epidemiological studies that considered particularly a lot of good data, and they were thought very informative. So they were weighted towards these in relation to lung cancer. Often when you're doing these evaluations, you have a lot of studies, you try to give weight towards the better. You just don't add them up and divide by the number of studies, but you give weight to the most informative studies. And 3 of these studies gave increased risks for non-stainless steel welders. Next point, in the opinion of the IARC working group, to quote, there's no evidence that these increased risks are limited to welding stainless steel based metals or specific welding processes. So in other words, they're really saying the risks seem to be extend to both mild and stainless steel in particular, and to different kind of welding processes. And last point here is, while some studies found increased lung cancer risk with gas welding compared to arc, it was sort of this might reflect differences such as temporal trends in the use of welding processes, characteristic workplaces, or linked work such as gas cutting. And I remember the discussions were very thoughtful and quite intense. The people they had at the working group had been involved very much with these studies themselves, so there was a lot of information going in. And the next slide, please. The conclusion from the IARC working group was that welding from gas and arc welding rather than welding as an occupation, has been done in the earlier one, was being looked at. And they stated that although welding fumes were not directly measured in the reviewed studies, exposure to fume was assessed indirectly through indicator variables, such as the process, the welding materials, branch of industry, job titles, expert assessment of self-report. And then they went on to say, since the association with lung cancer was observed for both gas and arc welding and could not be explained by other exposures, in other words, they looked at the other confounders and biases, such as smoking, asbestos, and trike, and so forth, that occur with these two predominantly welding procedures, the working group concluded that increased risk of lung cancer among welders can be attributed to exposure to welding fumes. So that was their final conclusion. Okay, now, since the IARC evaluation, another study came out, a meta-analysis. So there was a study which tried to look at a whole range of studies, including those that IARC had looked at. And this meta-analysis by Hanariara, published in 2019, after this monograph had been published, explored the variability, the heterogeneity between these various studies, just to see if there was any kind of more information you could tease out of the data. And it tried to quantify the magnitude of lung cancer risk against exposure, and explored exposure effect associations, which was quite helpful. And this really supported the IARC conclusion. So it was, if you like, an interesting backup to what IARC was saying, and so we could use this as well. The next slide, please. When it came to cancer of the kidney, the evidence of kidney cancer from welding was more limited in the IARC sense of the word, though two large census cohorts and 4 industrial cohort studies did show an increase. They weren't always statistically significant. They were positive, but not necessarily statistically significant. The confidence intervals encompass one, so the statisticians weren't happy that they were entirely comfortable with those. None of these studies adjusted for tobacco smoking, which, as we know, is again a risk factor for virtually every kind of cancer, or other potentially lifestyle confounders, although the working group considered it unlikely these could explain the observed observations. In other words, they could have been randomly distributed, these other various factors. So the working group came to the conclusion that there were consistent findings of elevated risk of several studies in different geographical areas and occupational settings, and used different study designs. However, not all findings were statistically significant. Most studies had only a few exposed cases, and there was little evidence of an exposure-effect relationship. And importantly, alternate explanations such as bias and confounding, which always have to be taken into account in epidemiological studies, cannot be therefore ruled out. So what IARC was really saying was, well, it's credible that kidney cancer could be associated with welding fume, but the evidence is limited, and therefore better studies will be needed before you could confirm this. But for the time being, you should treat it as if this is a potential possibility. So it was a fairly, if you like, a sound conclusion. Next slide, please. Okay, so we looked as a committee, this is WHEC, at the whole of the IARC monograph, looked at their conclusions, looked at the new evidence that came out, as we said, this meta-analysis since then, and WHEC essentially agreed with the current evaluation of IARC working group that exposure to welding fume can cause lung cancer, ocular melanoma, and possibly kidney cancer in humans, and there was more caution about that particular cancer. In most of the studies evaluated, the assessment of exposure was relatively crude. I mentioned this before. It's quite difficult to get good exposure data, and most people in most studies use years of exposure as the metric. It was primarily based on reported or recorded job titles. Welders often work on different materials, although often welding is actually very specialized, in spite of the fact that people look at welding and think it's quite a messy occupation, but it's a skilled occupation. And for instance, a lot of stainless steel welders, as far as I understood, tended to stay doing that because it's particularly skilled. But they did work with different materials, use different welding processes as the industry evolves throughout their careers. But some of the studies evaluated by the working group were able to distinguish periods of welding stainless steel, mild steel, or other metals. So in other words, IARC had tried to take this into account in terms of their exposure duration doing different kinds of welding. So we're comfortable they did a good job there. There was no evidence that the type of metal made any difference to the lung cancer risk. In other words, there's no particular kind of cancer that you can exclude as being risk-free, if you want to look at it that way. And so the WHEC is of the opinion that in determining the appropriate risk management measures that should be in place to control welding fume, no distinction should be made between different base metals being welded. And don't forget, we're not talking about here a class. We're not classifying. Well, WHEC is simply forming an opinion on terms of the scientific evidence. Next slide, please. This is where I move into John's area, so please forgive me for this. The slides will be available afterwards, so you can check yourselves on the information. Welding process is incredibly complex. Some of the terms you'll come across: MIG, MAG, metal inert gas, metal active gas. Often there is a shielding used to stop oxidation of the welding process itself. Welding is incredibly simple. You're trying to literally join metals together, which could be the same metal or different metals together. And there are different ways of doing it. There's the welding rod, there's the workpiece itself that you're doing it to. There's different forms of plasma arc forming an arc. There's laser arc, different ways involved in doing it. So the fume coming up is a mixture of the workpiece itself, the actual materials itself, what's in the welding rods, the metal that's being melted to fuse the two bits together, plus the gases that might be generated as a result of this, which might be inert gases and combustion gases. The particles can be in the form of a nano-sized material as well as a larger but still respirable particles. So it's an incredibly complex mixture. So you've got TIG, that manual metal arc, and many, many other processes. Next slide, please. Legal obligations in the UK, literally for welding, come under the COSH regulations, no difference. And don't forget, welding fumes is not classified as carcinogenic in the UK. It's simply a fume to be controlled by COSH. And the control, your legal obligations, like anything else, is to identify the hazards and assess the risk, prevent or control exposures, ensure control measures are properly used, maintain maintenance examination of the control measures, whether it's LEV or RPE, and inform and instruct and train workers. Monitor exposure if necessary and where you can. Provide health surveillance if it's appropriate. Give information, instruction, train to workers. In other words, the control is all part of the same hierarchy you'll find within existing COSH regulations. Next slide, please. Obviously, there are additional precautions if there are carcinogens within the COSH regulations. As I said, there are a number of things which might be carcinogenic, as we know, as chrome 6 and nickel there. HSE states with immediate effect, because of this, HSC, after the IARC monograph was published, they issued a safety alert for welding mild steel, which stated, in other words, we need to do a little bit more to protect workers than been the case in the past. However, to be clear, as I said, it's not classified as a carcinogen. So HSC immediately gave some more advice, particularly for mild steels, as noted in this particular slide by John, simply because mild steel was no safer, according to IARC, in terms of cancerous than stainless steel. And again, you must ensure the control of exposure of welding is in line with the principles of good practice as set out, as most of you know, in COSH. Next slide, please. Now, the principles of good practice for control, now this is a standard kind of hierarchy you would go through: design and operate process and activities to minimize emission, release and spread of fume. Now, as you know, that can vary quite a bit from in welding, from things which are highly controlled within booze, to off-site and in difficult situation welding. Control exposure by measures that are proportionate to the health risk. Choose the most effective and reliable control options. Where adequate control of exposure cannot be achieved by other means, provide in combination with other control measures suitable RPE. Well, don't forget, welders are being protected. Don't forget from heat, glare, and UV as well. So welding, there's standard procedures and equipment for welding anyway. So incorporated RPE to that has been well known for quite some time. Also, we have to check and review regularly all elements of control measures for their continuing effectiveness. It's a standard good hygiene practice. You put things in place, but that in itself is not enough. You simply have to make sure things continue to work to be effective. And of course, always important under COSH is informing and train all employees on the hazards of risk from the substances with which they work and the use of control measures developed to minimize risk. So essentially, what advice came out after the IARC evaluation from HSE was really just simply do what you're doing, make sure you're doing as well as it should be done. And of course, ensure that the introduction of control measures does not increase the overall risk to health. Think of unintended consequences by what you do by control measures. Next slide, please. So in terms of welding, we're having to assess the risks of health, identify the hazards, what metals are you using, and the kind of fumes that might be eliminated. Secondly, assess the risk, get information about who is the welder. Are they doing the welding all the time? Are they doing other jobs? Where, how, and for how long, so that controls are properly used. In other words, if people are doing welding as part of their job, you have some understanding of how much time is spent in this. Make a judgment about the magnitude of the exposure, or get an occupational hygienist to make measurements of exposure. Always this information is useful about the exposure, and getting a hygienist to give advice in terms of the control measures, and maybe getting exposure measurements give you some, if you like, understanding and reassurance about exposure levels and compliance with the existing workplace exposure limits, the occupational exposure limits we use in the UK. The process itself is an important determinant in the kind of exposure because of different fume formation rates between MMA, MAG, where there's no gas shielding, which is far greater than MAG, MIG, or TIG welding, where there much more control is. So all this information is available online from the HSC. So it's worth finding out about these things in the first place. Next slide, please. As I mentioned before, for individual components within welding fume, there are established workplace exposure limits. Usually these are time-weighted average, 8-hour exposure limits. And these can be assessed if you're unsure and need to measurements, and these are meant to be compliant with. Here's some examples here of some of the materials you might come across. For instance, iron oxide fume, quite common in welding, is 5 mg per meter cubed as an 8-hour time-weighted average. Aluminium oxide, sometimes aluminium welding, 4 mg per meter cube, and that's respirable, of course. Hexavalent chromium, which occurs predominantly in stainless steel welding, and there's quite a low 0.025 mg per meter cubed exposure limit for that. Copper, sometimes found 0.2 mg per meter cube. Manganese, 0.05, and that's as a respirable fraction. And nickel, 0.05 mg per meter cubed, water insoluble nickel compounds. And there are wells for other materials which may or may not be found. And again, all these can be found in EH40. The Get the Latest version is available online if you have any concern about any occupational exposure limits. And also in this document, freely available to download, EH40, you will find, apart from the workplace exposure limits, it gives quite useful advice on how to interpret these things, take the readings, and get advice from occupational hygienists. Next slide, please. Okay, assessing the risk. Well, as John put these slides in here, fumes arise from the weld itself. And you can imagine there's a great importance about whereabout the weld is. Welders, I've seen this, welders try to get as close to the weld as possible to make sure the weld is correctly done, to make sure the joint is patent, is working. So they often get as close as possible to get to the weld. And often one of the problems that I've seen in the past is they flip up the protection to look at the weld to make sure it's in place. So they can often lose protection. And you can see in this example, where the weld can be. So the head is where you get the exposure, and you can see it. The time the weld head is near, in the near field, is in the welding fume itself, and the time the arc is struck is important. All these factors could be important in determining the amount of fume that could be taking place. So this is quite important where the exposure can be. And of course, the size of the workroom, the amount of effectiveness, general ventilation, all this can make a difference to what's being done, often within or without a hood. Next slide, please. John put in some data here to show different exposures that have been measured. I think this was from a German paper where different forms of, 3 different forms of stainless welding were being undertaken. High steel, mild steel, stainless steel, and aluminium, between MAG, MIG, and TIG weld. And you can see there's quite a bit of difference in the, these were geometric means, so expressing the kind of data in the lower end kind of scale. And it gave the different kinds of data you were going to, exposures you were going to get from different kinds. So MAG and MIG were obviously much higher exposures than TIG welding. So the type of welding that's undertaken can make quite a difference to the kind of exposures people might get to the same materials. Next slide, please. There is a tool which is available, and John's given the link here to where you can get information. I think this was the BOHS tool, or was it the HSE tool? I can't quite see from here. So you can launch this tool and give you lots of information about welding fume control. And I think this was developed by the British Occupational Hygiene Society, and that I believe is freely available online. So a lot more information for different forms of fume control are available. Next slide, please. Now, there are control measures that you must use in a kind of way, and you must consider, can you replace a welding process? After all, if you're trying to join things together, do you need to use a hot process that will generate fume in the first place? I.e., are there cold joining processes that might work for that? And there's an HSC alert notice out there that gives you information on this. You must use local exhaust ventilation or some other effective engineering control. This can work to reduce most fume quite effectively if properly used. Regardless of the duration of welding, how long you're doing it for, HSC does expect LEV or the equivalent to produce the same kind of effect to be used. Well, when LEV is not sufficient to control exposure, then suitable respiratory RPE must be used in addition to the engineering controls. In other words, some kind of respiratory protection to stop the fume getting into the lungs. Appropriate RPE may be provided for welding outdoors. As I said, welding could be all kinds. Well controlled within a factory or workplace environment inside fume hoods where you can control things very easily, but outside on structures, think of shipbuilding, think of outside structures. LEV, if it can be used, it's got to be, but often RPE is what you might be left with. And if you are using RPE and you're relying upon it, it's got to be provided within a comprehensive program. Next slide, please. Well, there's information out there available on HSC's website. LEV, as you know, there are extraction booths and benches available this where people are using usually smaller components in a very standardized kind of fashion where things are much more controllable. And as you can see from the diagram, you can have mobile extraction arms even where you don't have particular booths, but you can use these things to make sure the fume is extracted as close as the point to where it's being emitted as possible. And or you might have on-tool extraction, which is fixed to the welding device itself, so it pulls the fume away as soon as the weld is on, and as close as possible to the welding piece itself that's being done. Then you've got personal protection and respiratory protection, filtering face piece, respirators, air-fed welding helmets where the air supply is coming from behind the area of the welding helmet itself, so you're pulling in a welding fume. Again, all this advice is available, so there's no reason why people should not access this advice from the HSC website. Next slide, please. I think this one moves by itself. As you can see, the whole principle being that you have control as close as possible to where it is emanating. There's no point in having LEV. It might make a lot of noise, but if it's not working in terms of moving the fume, it might as well not be there. So placement of LEV, particularly portable equipment, is absolutely critical for fume control. Is this one going to move or? From torch extraction. This is where it's attached. I think it'll give some idea. The LEV is being very placed close to where the weld is occurring. Most of the fume being pulled up. If it isn't, it's simply allowed to get into the welder's breathing zone. Okay, UV exposure to the eyes and the skin. There are frequent reports of erythema, in other words, sunburn, and photokeratoconjunctivitis, in other words, welder's eye. I think I've had this in the past. Often this is done, if you like, casual observers around a welder can get, this itching eye. It feels like sand in the eye, simply standing by and watching people weld. So it can occur, but welders know well enough to avoid this. UV irradiance to the face and eyes are very high during welding, and even when wearing protective visors, the exposures can exceed guideline values, so not to be underestimated. Melanoma of the eye is relatively rare. We don't get that many cases, and the number of cases of the disease in the UK caused by welding is likely to be less than 10 a year, but it is a possibility and not very nice. And as I said before, the IARC gave a positive to this in terms of group 1, but did point out there was limited evidence to that, and couldn't point to where exactly which part of the eye it was in. Also, of course, must not forget welding can cause ordinary skin cancer, like UV light, but the indirect evidence is quite limited to this. Next slide, please. There are a lot of helpful resources out there. I mean, HSC has put out a lot on welding, and so you can go to the website. The Koch welding advice sheets are available online. The British Occupational Hygiene Society have a welding selector tool, which is extremely useful to give advice, to supplement what comes out from the Health and Safety Executive. For choosing LEV and RPE, there are advices given there to those, both on the HSC and for UV. John has pulled out quite a useful, no disrespect to UK HSC, because, well, UV, Australia have a lot more UV than we do generally, put it that way, just by living there. Very good, useful on their WorkSafe website. Now, as I mentioned before, all this slide presentation will be available afterwards if you need any further information that's on the slides itself. And I think at that particular point, I'll stop.